All right, so now we're going to get into chapter 14, section 3, which is all about trigonometric functions. So looking at relationships between the lengths of sides in a right triangle. So these are really commonly used in application and things that you did see before, again, in geometry, but a really good time to go back over that and lay some foundation for some more applications. So trigonometric functions. So we're talking about things like sine, cosine, tangent. All these are just ratios of sides in right triangles. So we're going to spend quite a bit of time talking about this. All right, so let's do a couple just refreshers here, make sure we know what we're talking about. So just a couple recall things. Quadrants and signs. So looking at which quadrant is which and making sure we know where we have positives and negatives. So what I'd like you to do is go through and name your quadrants here. So stop the video. Where's quadrant 1, 2, 3, and 4? And then think about what you know about X's and Y's in each of those quadrants. Where are things positive and negative? All right, so we start with quadrant 1 up here. So we have quadrant 1. In quadrant 1, we think of ordered pairs, X comma Y, those locations. The X is positive and the Y is positive. As we move into quadrant 2, so counterclockwise, I wanted that in a different color. So quadrant 2, our X's and Y's over here, we had to go left, so that would be negative and then positive. And we keep going around here down to quadrant 3. I usually use Roman numerals for this. So your X, Y values down here, you had to go left and down. So both directions were negative. And then we end up in quadrant 4, where again for our X, Y's, for our ordered pairs, we went right and then down. So positive and then negative. So when we think about where our values are and things, we should always be able to know our location, what quadrant we're in, by knowing our signs. Okay, so now we're going to talk about what are these functions, sine, cosine, and tangent, the things you see on your calculator. So we're going to be using this picture off to the side. So I want you to think about if you have an angle measurement in standard position. So that's a really important part about this conversation when we look at this in the coordinate plane. So our vertex is at the origin. So this blue, and I want to kind of highlight this so you can see it. The angle measurement that they're talking about is this one right here. And then we're talking about locations of this angle measurement. So standard position, they're doing a positive angle here because we went counterclockwise. So if you take any point on this terminal side of the angle, so they just pick this point B, they're using labels to help you kind of talk about where it is. That location is going to have a point associated with it, an X and a Y, an ordered pair. What that means is, though, you had to go right a certain distance, which is the X value, and then you had to go up a certain distance, ooh dear, that's not very straight, which is the Y value that associate with that ordered pair. So we have this horizontal distance that we went and the vertical distance to get to that location. So instead of just rotating through and thinking about this angle as a rotation, I can think of it as going right and then going up. Now, the other thing that we can keep track of is we could also keep track of how far we are from the origin out to that location. And they're going to call that R. R for radius, almost like thinking of as this was a circle, like a distance from the center. So think of it sort of that way. So they call it R, and we'll talk a lot more about that as the year goes on. So we want to be able to talk about this location and how we can evaluate things. So I want you to think about this picture for a second. This is a right triangle. So we know some things about right triangles. We know that it follows the Pythagorean theorem. So a leg squared plus a leg squared equals the hypotenuse squared. So something that I can say about this is that the x squared, so that base squared, plus the y squared would be equal to that radius squared. Trying to keep color coding here so you can tell what's happening. So in that right triangle, x squared plus y squared would be r squared. So I could pretty easily solve for r by square rooting. So the radius would be equal to the square root of x squared plus y squared. So I can actually calculate that pretty easily. If I know the two legs, the location, I'm going to be able to find how far it is from the origin as well. So that's going to be part of those ratios. It's one of the three sides of the triangle. So I have to be able to find that as well. Okay, now I want to see what you guys remember about sine, cosine, and tangent. They are ratios of sides in a right triangle, and we're going to be using the perspective of this angle A down here. So this angle A, that's where the vertex is. So we're going to be always using a point of reference. So it's really important to know which angle you're using. So I'm talking about angle A. So with respect to angle A, I have ratios of the triangle. So sine is a particular ratio. I'm going to use the words first. Cosine is a ratio, and so is tangent. If you remember kind of the saying SOHCAHTOA, I'm just going to write it up here. That's a good mnemonic device to help you remember what these ratios are. The sine, so S, is the opposite side over the hypotenuse. So the opposite over the hypotenuse. All right, now let's see if we can label what each of these are. From perspective of A, opposite means it's the side across from. So I'm going to go ahead and label these, and please put them in on your picture as well. The side opposite is the one that's all the way across. Like if you're sitting opposite someone at a table, you're across the table from them. The hypotenuse, always across from the right angle, so that's the same as the R. So go ahead, hypotenuse. Go ahead and get that labeled in there. So we can label it with the words opposite and hypotenuse, but I can also label it with what they're equal to. The opposite side is this Y, and then R. So usually when we talk about sine, we talk about opposite over hypotenuse, but we're also talking about Y over R. It's that height of the triangle over the hypotenuse, or that R value. Okay, so cosine, cos. So adjacent over hypotenuse, if these words are sounding familiar to you. So adjacent side over the hypotenuse. Okay, so now for this one, adjacent we have to label. So what's adjacent to angle A? Well, that's this side X. So I'm going to go ahead and label this. This is adjacent. If you're adjacent to something, you're right next to it. It's connected. So if I'm sitting adjacent to you, we're right next to each other. So A is right next to this X here. They're connected. That's the adjacent side. So this would be X over, and then the hypotenuse is R. So cosine, this function, is defined to be that ratio, X over R. And then tangent, another ratio. If you remember TOA, so I'll go back up to here. So tangent is opposite over adjacent. So it's the opposite side over the adjacent side. That's an E. All right, so opposite side, remember again, is Y, and then the adjacent side is the X. So like rise over run. So a lot of times people, when they're thinking about tangent, they're thinking about slope. Rise over run, if that's all tangents are, is steepness. How steep is that? So what's the ratio of Y over X? So these are the three big functions that we talk about. Now I want to make sure that you know what their actual names of the functions are as well. So I'm going to put those right below. When you say this, this is the name of the function. It's sine, S-I-N-E. Cosine, we'll talk about why it's cosine in a later chapter. They're co-functions. So cosine, and then the last function's name is tangent. So make sure you know which function you're talking about. When you're abbreviating them, you're still saying the name of the function. So when you see that S-I-N, you say sine. It's the sine function. All right, now we're going to be using a lot of different things to represent different angle measurements. So we'll come back and talk about that theta here in a second. We're going to talk about the reciprocal function. So there are the original three functions, so we have those, but there's also something called the reciprocal. And if you remember what a reciprocal is, if you have a fraction like 2 over 3, its reciprocal would be 3 over 2. So the reciprocal functions are exactly that. They're taking these original SOHCAHTOA ratios and doing their reciprocals. So we're going to use the same picture. So we have X, Y, and R. And remember, for this relationship, we're using the perspective of angle A. If you notice that in all of your labels, that's really important. We have to know which angle we're using because opposite and adjacent is different. If I change my perspective, right? If I use a different angle, what's opposite me and what's adjacent to me changes if I move. So make sure you know what angle you're using. So I'm going to go back from my other one. Opposite over hypotenuse was that Y over R. Adjacent was X over R, and then opposite over adjacent was Y over X. So those are our original functions. Now we want to make sure we know what the names of their reciprocals are. And these kind of don't make sense when you think about it. They don't really connect. But the first one is CSC. That's reciprocal of the sine function. So they go together. So I'm going to write out how you say it. Cosecant. That's the name of the function. So make sure you write down the word too. Is the reciprocal for sine. So where sine was opposite over hypotenuse, this is going to be hypotenuse over opposite. It's just reciprocal. So that means instead of being Y over R, it's going to be R over Y. So the name of the function is cosecant. It goes with sine. All right, now I'm going to kind of draw a line here so we can keep these separate. All right, now cosine goes with secant. So the name of this function is the secant function. It's the reciprocal of cosine. And again, we're still using that perspective of angle A. Its ratio, again, if cosine was adjacent over hypotenuse, This one would be hypotenuse over adjacent. So that means that's going to be R over X. So it's literally the reciprocal. All right, and I'm going to draw a line here again so we can keep these three separate. Cotangent. So cotangent is the reciprocal for tangent. It's really the only one that people can be like, oh, okay, that makes sense. At least they sound sort of similar. If cotangent or tangent was opposite over adjacent, that means cotangent is going to be adjacent over opposite. So that means if it was y over x, now it's going to be x over y. So if you know the original three functions, finding their reciprocals, and maybe you didn't talk about these at all in geometry, but they're really pretty straightforward because we know how to do a reciprocal. So it's just remembering the names that go with things, and that's the hardest part here, is remembering those definitions. So here's what we're going to do. We're going to do 4 examples to talk about how do we calculate these ratios. How do we do that in our triangle, keeping track of our locations. All right, so we're going to go through several examples to try to help you kind of work through this. So we're going to figure out where our angle was, where this location was, so what are our x and y values, and be able to write out the ratios then by looking at the triangle. So we're going to find the 6 trig values of angle. So we're going to use this theta. So I'm going to go back to that conversation. I kind of skipped it, but now it makes sense to talk about. So on the second slide here. So there's a Greek letter theta. Oh, geez, go down there. There's a Greek letter theta, so it's kind of like a 0 with a slash through it, that's commonly used to represent an angle measurement. So you're going to see that a lot because sometimes they don't use like a capital letter necessarily to always be an angle. So they're talking about a theta here for this one. So this is just the angle measurement. So that's the symbol that we're going to use for it. That passes through the point 12, 5. So 12 is your x and 5 is your y. It's your ordered pair. Now think about where you're located then. You're going to put this in standard position. If you do 12, 5, that's positive, positive. You're going to end up in quadrant 1. So when we draw our picture, it's going to be in quadrant 1. So the terminal side of this angle, this point, is going to be located in quadrant 1. So to place the angle in standard position, the initial side always has to be on the positive x-axis. So let's draw this angle. So they're talking about an angle that starts here, and its terminal side goes through the point 12, 5. So I'm going to go ahead and think about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, approximately 1, 2, 3, 4, 5. So its terminal ray is going to go through the ordered pair 12, 5 in quadrant 1. So if I drop that perpendicular down, this is the triangle that we're talking about. So the angle measurement, this theta, is this angle at the origin. So when you're thinking about your picture, that's what they mean by that. So my x is 12 and my y is 5. So the location, the dimensions of that triangle, the x value is the horizontal and the y value is the vertical. Now, oops, I should have put the x, I guess. I'm going to try to follow the colors that they're doing there. I'm going to put my x in blue, looking back over here. So I'm going to make that blue just so we can follow what it is over on the other side. All right, so what's the only piece of the triangle I don't have? Well, I don't know that hypotenuse, right? I don't have that distance from the center out to the point, so I need to calculate my r. And remember, that's just the Pythagorean theorem. So 12 squared plus 5 squared equals r squared, and we're just going to solve. So 144 plus 25, which gives us 169. And then I square root. Now, normally we talk about plus or minus. I don't need plus or minus though, because it's the length of a side of a triangle. So it's just the square root of 169, which is 13. All right, so this side is 13. Now I'm going to go ahead and label with our other words that we use too for SOHCAHTOA. And again, we're using the perspective of angle theta down here by the origin. So which side is opposite that? So if I go all the way across the triangle, the opposite would be the 5. Which side would be adjacent? Adjacent means connected to, so the 12 is the adjacent. And then my hypotenuse is always the longest side, and it's across from the 90. People get adjacent and hypotenuse mixed up a lot. Just remember the hypotenuse always has to be the longest side. Okay, so what are we going to do? We're going to write the ratios. So sine of theta, so this is our perspective down here again, is y over r, which is opposite, remember, so think about your words, opposite over hypotenuse. So I'm going to go ahead and write that ratio. So opposite is 5 over hypotenuse, which is 13. Trying to keep the color coding here. Now, if you can simplify your fraction, great. If you can't, just leave it. All right, so right away, I'm going to go ahead and do its reciprocal. Cosecant then is just the reciprocal of that, which would be 13 over 5. So it's the same ratio, but just flipped, cosecant. All right, now let's do cosine. So cosine is x over r, or if you want to use your words, adjacent over hypotenuse. So let's take a look at the picture here and see what that means. So adjacent, what side's adjacent? Well, that's the 12 over the hypotenuse, which is 13. And then I'm going to go ahead and do its reciprocal. The reciprocal of cosine is called secant. That's just a definition that we just need to know. So cosecant then would be 13 over 12. So it's literally the reciprocal. All right, tangent, SOHCAHTOA, like the slope. How steep is that terminal side, that ray? So remember what tangent is, opposite over adjacent. SOHCAHTOA, opposite over adjacent. So we're going to look at our opposite side, which was 5, over the adjacent side, which was 12. So it should be 5 over 12, which means cotangent then is going to be the reciprocal, which would be 12 over 5. So if we can find the original 3, these first 3 in that column, really easy to find their reciprocal. So the SOHCAHTOA ratios are just talking about ratios of 2 sides in the triangle. Ultimately, what we're going to be able to do then is solve for angle measurements as well. So we can solve for anything in a triangle, and that's kind of what our ultimate goal is here. For real life applications, what can we solve for? So drawing the picture, finding that other side, and being able to express what those ratios are. All right, so we're going to take a look at a couple more. We want to talk about different quadrants, so we can talk about signs of things too, because it's not just about length, it's also about direction. All right, so it says the terminal side of your angle this time in center position passes through the point -3, 4. So we're starting with our initial ray here, -3, 4. So can you go ahead and graph that? -3, 4 would be in quadrant 2. So our terminal ray is going through that point -3, 4. So that's the angle that they're measuring to get to that location. Okay, so what's the triangle then that they're talking about? So the triangle that they're talking about is always dropping the perpendicular down to the x-axis, back over to the origin, and then that distance at that point is from the origin. So that's the right triangle that they're talking about. This is the theta that they're trying to express for you. So they want you to use the angle, that what we call the reference angle. We'll hear more about that later too. The angle with the origin there. So this distance from the origin out to this point is that radius that we were talking about before. So here's our location, -3, 4. What does that mean? Well, that means we went -3 in the x direction. So -3 meaning negative, we went left and a distance of 3, and then +4 in the y direction. So our adjacent and our opposite are going to be those 2 values. So adjacent, remember, is connected, and opposite is across the triangle from the angle measurement. We still have to find r though, right? We still need to know what that value is, that third side. Be aware when you do your a squared plus b squared equals c squared here, we got to be careful with that negative sign. So when you square a negative, it is a positive. So just be cautious there. You would end up getting a +9. So 9 plus 16 would be 25. And then we square root, so our radius would be 5. So that third side of the triangle is going to be 5, the hypotenuse. So always be thinking about when we draw the picture, it can be a little trickier when it's in a different quadrant. We need to think about what those values are. Okay, so let's see if we can set up these ratios. So sine, SOHCAHTOA, I'm going to go ahead and put the labels in. Opposite was 4, adjacent was -3, and our hypotenuse was that 5. Okay, so y over r, so that's opposite over hypotenuse. Take a moment, go ahead, pause the video, see if you can fill in what sine would be. So opposite was 4 over the hypotenuse, which was 5, so 4/5. So that means our cosecant reciprocal would be 5 over 4. Always reciprocal, that's pretty easy to do. All right, so pause the video, try cosine, SOHCAHTOA, try cosine. So that's adjacent over hypotenuse. All right, so the adjacent side, what's adjacent to that angle, so what's connected to it is the -3, and the hypotenuse was 5. Oops, that was supposed to be green, 5. And then that means secant would be 5 over -3. Notice the cosine is negative. Cosine is negative in quadrant 2 because x's are negative. That's just direction. The ratio is still the ratio, but you went left, so that's why that would be negative. All right, try tangent. Go ahead, pause the video, try tangent. So we've got opposite over adjacent. See if we can write those ratios. So opposite would be our 4 over adjacent, which is -3. So that means cotangent would be -3 over +4. So tangent is also negative in quadrant 2. And think about that. If you look at that ray, that terminal side, doesn't that have a negative slope? We're doing rise over run. Well, that's negative for sure. So tangents, when we're in quadrant 2 or quadrant 4, actually, are going to be negative because we have that, that going down and then over, or left and then up. All right, let's try just a couple more and make sure that we're okay with these ratios, and then I think we should be in good shape. I'm just trying to hit different quadrants so you know how to solve for those angles. All right, so we're going to do an angle that's in standard position. So starting here, that goes through the point -2, -3, which looks like it's right down there in quadrant 3. So there's our terminal ray. So we're talking about that measurement. But what triangle is that? Go ahead and drop the perpendicular back always to the x-axis, over to the origin, and then you have your triangle that we're looking at. So this is that theta that they're talking about, always with the origin. So let's put in our dimensions. Our adjacent side to the angle right on the x-axis, that went -2. And then our opposite side, or the height, was -3. So again, the negatives are direction. I know it seems really weird to put in a sign like that, but those are just directions. So our adjacent was -2 and our opposite is -3 across from the angle. Remember, opposite. Now we need to find our radius, the distance from the origin. So calculate r. Again, very cautious when you square negative numbers. You should get a positive answer, right? So 4 + 9 = r squared. So r squared equals what? 13 square root. Oh dear, this is the first time we didn't get a whole number. No worries. Leave it as an exact answer though. So if it's not a perfect square, I'd rather have you leave it as just a square root like that, so we can have an exact answer when we look at those ratios. Okay, so SOHCAHTOA here. So we're going to do sine first. It's opposite over hypotenuse, or y over r. So opposite is -3 over the hypotenuse, which was, I'm going to fill it in on the picture, square root of 13, right? Ooh. All right, so I know we talked about this before, rationalizing that denominator. I don't want to leave square root of 13 in the bottom if I have to work with this number. So I'm going to multiply top and bottom of that ratio by square root of 13 to rationalize it, make it a nicer number to deal with. Square root of 13 times square root of 13 is the square root of 169, which is just 13. It just makes this number a lot easier to look at and work with. So we're going to try to rationalize if we end up with a radical in the bottom. Okay, now which one on the bottom here is the reciprocal? I'm going to kind of draw a line here of sine. Well, that's cosecant. So I'm going to go ahead and do that one right away here. So remember, a sine was -3 over square root of 13. We're going to do the reciprocal. So that means it's going to be square root of 13 over -3. Now notice here, I don't have to worry about doing the rationalizing because there's not a radical in the denominator, which is great. Don't have to worry about it. All right, let's go ahead and do cosine. So cosine, adjacent over hypotenuse, which would be what ratio here? Well, adjacent looks like the -2, always that horizontal distance, over the hypotenuse, which is square root of 13. We run into that same issue we did on the last one, so I'm going to rationalize. Now, multiplying the top and the bottom by the same value is totally fine. That's like multiplying by 1. So we rationalize it. We made it a little bit easier number. Okay, now which one on the bottom is the reciprocal for cosine? That one's the secant, right? So we're going to flip our original function here for cosine. We're going to do the reciprocal. So it's actually going to be square root of 13 over -2, trying to color code here. This one, again, we don't have to rationalize because we already have a whole number on the bottom, which is great. So we don't ever have to rationalize one of them. All right, let's do tangent. Last one. That one is opposite over adjacent. So y over x, opposite over adjacent. So that would be a -3 over a -2. A negative divided by a negative, though, actually ends up to be a positive 3/2. And think about it. If you look at this or this radius, this terminal side, it's going up and over. So positive divided by a positive, or a negative divided by a negative, that is a positive slope line. Remember, tangents are slopes. So that makes sense to me down in quadrant 3 why that would be a positive number. Now when we do its reciprocal, so it goes with cotangent, that's going to be the same idea. It's just going to be adjacent over opposite. But by the same argument, that's going to end up to be positive as well, negative divided by negative. So if the original was 3/2, then we'd have to have 2/3. So just wanted to talk about something that was in quadrant 3 where both x and y are negative. That means tangent's going to be positive. All right, our last one we're going to do with numbers here is kind of a special case. This one kind of bothers people because it doesn't really look like the other ones. And then we'll kind of wrap things up here. So find the 6 values of a trigonometric function for an angle theta in standard position with a terminal side that goes through 0, -5. Okay, so I want you to graph this. So a standard position angle. So that means we have to start at the positive x-axis, and our angle is going to go through 0, -5. Well, that's just over here. 1, 2, 3, 4, 5. So that means we measure this angle, and our terminal ray is over here. Now, a lot of people look at that and say, what? How can that be possible? Well, isn't that just 180 degrees? That's definitely an angle, right? We can definitely express that. It's just, it doesn't really look like a triangle anymore. If you think about when we draw triangles, as this terminal side gets closer and closer and closer and closer, the height gets lower and lower and lower and lower and lower until all of a sudden we just end up at a straight line. So when we think about SOHCAHTOA ratios, there doesn't actually have to be a triangle. We just need the relationship between the sides. So we need opposite, we need adjacent, and we need the distance from the origin, which might be a really nice way to always think of that r or that radius. So I'm going to go back here when it said calculate r. So it's the hypotenuse, right? I'm going to add this in here. So it's the hypotenuse of that triangle. But we can also call it the distance from the origin. And that might make a little bit more sense when we have points that are on either the x or y axis. It's the distance from the origin as well. So I'm going to think of it that way for this one when I start talking about what's happening for each of these values. So my x is definitely 0, right? I know that's my x value. My y is definitely -5, right? So that's my y value. I can solve for r the same way. Otherwise, I can just count. How far is it from the origin out to that point? Well, that's a distance of 5, right? These are always positive too, right? These r values, because it is a distance. You can do the Pythagorean theorem. 0 squared plus -5 squared equals r squared. So 0 plus 25 square root of 25 is 5. So you can do the work if you want to, but it's going to be the same thing. So you still have x, y, and r. So we still should be able to find those, even if we don't necessarily think of it as opposite, adjacent, and hypotenuse. So it might be better to think of this one as y and r and x when we write our ratios. Okay, so what would sine be at this location then? Well, it's going to be y over r. So y is -5, and the radius is +5. Oh my goodness. I did -5, 0, didn't I? I did. You're probably wondering what the heck is going on here. 1 second, let me fix my... Okay, so what we're going to do is we're going to actually, I'm just going to do what I drew. So let's go ahead and just change the example. I'm sorry, I wrote it kind of the wrong way. I said x is 0 and y is -5. I just graphed that picture wrong here. So let me fix that. All right, so sorry about that. My brain is obviously not working. 0, -5 is on the y-axis. Help me. See, we all make goofs here. So when I'm thinking about what angle that they were talking about, it was this one. So 270 degrees, 0, -5 going down. The distance from the origin, still 5. All of those calculations were fine. I just drew my picture wrong there. So that radius or distance would be 5 units from the origin. So my y over r, so -5 over 5 works out to be then -1. So in other words, the distance, the opposite side and the distance from the origin, the r, are equal. And it's negative because we went down, right? So that negative in the y direction. Cosecant's going to be the same thing, just reciprocal, right? So I have those next to each other. So we'd have 5 over -5, which would still be a -1. All right, let's talk cosine for a second. X over r. So the x value is 0, and the R value is 5. So remember, 0 divided by a number, that's just 0. Cosine, remember, is the adjacent. Well, we didn't go left or right at all. There's distance was 0. There was no adjacent side. That's why that's 0. So when we're on the y-axis, that makes sense to me when I see that. Now, secant, careful when you do this, you end up with 5 over 0. When you do 5 over 0, I can't divide by 0 and get a real number answer. So that's going to be undefined. So we do have some of these when we do reciprocals that we're just not going to be able to calculate. All right, tangent. Before I have you actually do the calculation, I want you to remember back and think about vertical lines. What is the slope of a vertical line? Do you remember what those are? Slope of a vertical line was undefined, right? There's no number for that. Now take a look at what happens when you do the ratio. Y is -5 over x, which is 0. Can't divide by 0. That's undefined. That's why it's really helpful to think of tangent as slope. And then cotangent, we flip. So we get 0 over -5, which would be 0. So finding those reciprocals, we're just flipping. Again, if it's undefined, the reciprocal should be 0. So that kind of makes sense. So for the ones that are on either the x or y axis, we kind of have weird ratios when we look at that are different. We, instead of having like 2 over 3 and things like that, we end up getting 0s and 1s and undefined. So it's because 90, 180, 270, 360 kind of unique locations. The distance, it looks a little bit different. They don't really look like a triangle anymore, but we can still do the ratios. We still have the y, the x, and the r, and we're going to solve it the same way. Just remember, always think about that radius as the distance from the origin, and that will really help. It doesn't always have to look like a triangle. All right, so let's think about signs for a second here, just thinking about what makes sense, and then we'll kind of wrap this up. I know it's a little bit longer lesson to look at. So if you're in quadrant 2, I want you to think about what sign your answer should be if you're doing x over y. So going back to kind of what we talked about that very first slide, when you're in quadrant 2, you go left and up. So it's negative and then positive. So that means the x value is negative and the y value is positive. So what would be the sign of your final answer? A negative divided by a positive would be a negative answer. So my answer would be negative if I'm in quadrant 2 for that ratio, which would be a cotangent, by the way. If we're in quadrant 4, so let's think down here, quadrant 4. What do we know about ordered pairs there? Well, we went positive to the right and then down. So positive and then negative. So my y value was negative. The r is always positive. It's a distance, so it's always a positive number. So no matter what, r is always positive. It's the distance from the center of the origin. So you'd have a negative divided by a positive. That would be a negative answer again. Always thinking about just what the ratios are going to look like. Quadrant 3, let's do that one. So if I'm in quadrant 3, y over x. Well, remember how we get to quadrant 3? We go left and then down. So a negative and a negative, which means we're taking a y that's negative, dividing by an x that's negative. What's a negative divided by a negative? Positive answer. So when you're doing these ratios, just kind of always that last minute kind of double check. Does this make sense? Think about what those signs should be. All right, make sure that when you're working with these, if you're ever using your calculator moving forward, we want to make sure we're in degree measure. So we had a big lesson today, you guys. This was a really important one on making sure we know the trigonometric functions, sine, cosine, tangent, that's SOHCAHTOA. What are their inverse functions called? Cosecant, secant, cotangent, being able to draw those triangles using the Pythagorean theorem to find that hypotenuse, and writing out the ratios, keeping track of direction. Where am I located? So really big section to talk about.